Derivatives with E, product rule, Lagrange's notation. So, when you have e to the power of x, and you're wishing to derive it, the derivative, funny enough, is e to the power of x. It's the same thing. But when if you were to derive e to the power of kx, k being a number, any number, then you would have that number, k, multiplied by e to the power of kx. Notice that when you derive ex, or e to the kx, it stays the exact same, except when you have a number, when you have e to the power of a number kx, you bring that number down. And that's only because if you were to derive kx, you would end up with k. So this number here is actually the derivative of what's inside these brackets. Because there's no derivative, because e to the power of x, because the derivative of x is 1, essentially the derivative is 1 times ex. I'll do some examples and show you a bit, and hopefully you can understand if you don't, but if you do, keep watching if you wish. But here's just Lagrange's way of doing the product rule. You have a function hx, within it you have two functions multiplied by one another, fx and gx. This is what I labeled them as. And the derivative of hx is the derivative of fx multiplied by gx plus fx multiplied by the derivative of gx. Let's start with an example. hx equals x squared multiplied by ex. So that's when we have a function being x squared multiplied by another function, that being e to the power of x. So if we were to split the page and label as such fx and gx, fx we will label as x squared and gx as ex. The derivative of hx, following the product rule, is the derivative of fx multiplied by gx plus fx multiplied by the derivative of gx. Now, we need to find the derivative of fx and the derivative of gx. So, the derivative of fx, fx being x squared, will be 2x. And the derivative of gx, gx being ex, is just ex. As shown before, when you derive just ex, you end up with just ex. So if we were to fill these values in, we would end up with 2x, because that's the derivative of fx, multiplied by gx, which is ex, plus fx, x squared, multiplied by the derivative of gx, which is just ex. Now, because we have 2x multiplied by ex plus x squared multiplied by ex, we can sub these out as such. Because if we were to expand these brackets, we would end up with ex multiplied by 2x and ex multiplied by x squared, as such here. So this is just a simplified, neat way of doing it. We can also rearrange it because you usually have the highest power out the front. And that there is the first derivative of the function up here. Okay. On to another example. Ex multiplied by tan of x. So we have two functions, ex multiplied by tan x. If we separate the page and label them, we make fx ex, we make gx tan x. So the derivative, the formula for the derivative for following the product rule is f dash x multiplied by gx plus fx multiplied by g dash x. So f dash x, the derivative of fx is ex, because the derivative of ex is just e to the power of x. The derivative of that is e to the power of x. But the derivative of gx, the derivative of tan x, is sec squared x. So if we were to rewrite this out, we'd end up with f dash x, which is ex, multiplied by gx, which is tan x, plus fx, which is just ex, multiplied by g dash of x, which is just sec squared x. So, as before, because we have ex multiplied by tan and ex multiplied by sec squared, we can bring the e to the power of x outside brackets as such, factoring out. So if we were to expand these brackets, we would end up with this up here. This is just a neater one, like I said before. And if you wanted to go a bit further, because you make the highest power at the front usually, that there would be the derivative of this function up here. Now, onto a third example. Let's say hx, example 3, hx equals e to the power of 2x multiplied by x squared plus ex. So, just like before, we have a function e to the power of 2x multiplied by another function x squared plus e to the power of x. So if we label them as such, fx we can label as e to the power of 2x, and gx we can label as x squared plus ex. Derivative of f multiplied by g plus f multiplied by the derivative of g. So we need to find the derivative of f, and we need to find the derivative of g. The derivative of f, the derivative of e to the power of 2x is 2e to the power of 2x. Because like I said before, essentially you just bring down the number, but the theory behind it is that you derive whatever's to the power. In this case it's 2x. You would derive that and then multiply it back onto the e to the power of 2x. As such, we have e to the power of 2x, the derivative of 2x is just 2. So, we have e to the power of 2x multiplied by 2. Essentially you have e to the power of whatever, and then when you derive that, you have e to the power of whatever multiplied by the derivative of that whatever. But, back onto this, gx being x squared plus e, the derivative of that is 2x plus ex, because derivative of ex is ex, and the derivative of x squared is 2x. So, if we fill this in, what we end up with is derivative of f, 2e 2x, multiplied by g, x squared plus ex, plus fx, fx being e2x, is the power of 2x, multiplied by the derivative of gx, which is just 2x plus ex. I'm not going to go any further with this. You can if you wish, but I'm just going to leave it as is. I'm sure if you were to get a question like this and you did it to this stage, a teacher would be happy. I can't guarantee that, but if you wish to, you can derive this for your sake or enjoyment. Thanks for watching. Hope this video helped.